How have polymers influenced sportswear and the way athletes perform in it? From golf to swimming, all kinds of athletes rely on sportswear to give them a competitive edge. The last thing you may think of when exercising is how polymers have helped develop sport, but they are at the heart of it. Polymer manufacturing has helped produce materials that are lighter, more durable, and provide better performance features. This video will delve deeper into how polymers have impacted sportswear and why they are important for athletes looking to excel in their field. Looking back to ancient Greece, athletes competed in the nude or sported short-sleeved tunics of linen. This is a far cry from where we are today. So how did the industry of sportswear change so drastically? In the 19th century, there was a new focus on sports and competition. This was due to the Industrial Revolution and the greater availability of time. New specialised clothing such as woolen suits became available, and new advancements came with fibres like cotton and silk becoming popular in sportswear. In the 1930s, new synthetic fibres like nylon and elastane were developed but were not widely used yet. Nowadays, the industry makes a much greater use of synthetic fibres. These are much more suited to exercise with properties such as greater flexibility and moisture wicking abilities. So let's first look at the composition of cotton and why sportswear has moved away from using it as its main component. Looking down to the polymer level, cotton is made of cellulose. Cellulose is a macromolecule and is made up of the repeating units of the monomer anhydroglucose. These are glucose units with water eliminated. This is where the phrase anhydro comes from. The cellulose chains within the cotton fibres are held together in place by hydrogen bonding. These occur between the hydroxyl group of adjacent molecules to create intermolecular forces, and also in the repeating units themselves to create intramolecular forces. Because of the extensive hydrogen bonding between hydroxyl groups of cellulose, the fibre of cotton is hard to break apart, so it is strong fabric useful for clothing. This means it's durable, which is useful for sporting activities. The downside to cotton is its high absorbency. This is because it's hydrophilic. Water is attracted to hydroxyl groups and can hydrogen bond to cellulose. The pores in the fibres can fill with water. If you sweat a lot, this can be a bit embarrassing. Luckily, there are ways to increase the drying speed to make cotton more suited for sportswear. Finer yarns can be used, it can be treated with hydrophobic materials, and blended fabrics can be used. Bilayer fabrics can also be utilised, which have different face and back layers. One face is hydrophobic and the other hydrophilic. So cotton might not be the best suited for sports clothes. What new alternatives have been made that are used extensively in athleisure wear? First up, nylon. Nylon is made from dicarboxylic acids and diamines to form polyamides such as nylon 6,6. Each molecule is added onto the end of another molecule and a long-chain polymer is formed, a macromolecule. This is known as step growth or addition polymerization. Hydrogen bonding can occur from the hydrogen of the amine group and the carboxyl group of the carboxylic acid. This means that nylon is strong and durable because the chains cannot slip past each other. Hydrogen bonding can also occur with water, so it is slightly absorbent, but much less than cotton, due to less sites available for hydrogen bonding. Nylon blends can increase the elasticity and has no discoloration by light. Now we shall move on to a polymer that is famously used in sportswear. It is the second most used polymer in the category, elastane. Elastane is made up of a copolymer of diisocyanate, which has two cyanate groups at the end, and a macroglycol, which has two hydroxyl groups at the end. It contains two sections, a soft rubbery segment and a rigid segment. The soft segment provides elasticity because they are disordered. This makes the fabric soft. The rigid segment is strong due to the aromatic nature. The section can bond with each other and give a rigid crystalline structure. Elastane is made when the hydroxyl groups of the macroglycols react with the isocyanate group of polyurethane. Each monomer is added to the end of the molecule, so again it is a step growth polymerization. A catalyst is needed to initiate the reaction, and stabilizers such as antioxidants are added because the fibers are vulnerable to damage from heat, light and chlorine. Its main attractive feature to sportswear is its ability to stretch. If a force is applied to the fabric, the bonds between the rigid sections can break, which allows the soft sections to extend, which lengthens the fibre. This can recoil when the force being exerted is removed. it also has a high breathability. So what would happen if you discard some sportswear? It will most likely end up in landfill, unfortunately. Even though synthetic fibres have made many modern advancements, they generate a lot of waste. 60% of waste found in waterways is made of non-biodegradable fibres such as nylon and elastane, and 35% of microplastics found in the environment is due to washing synthetic clothing. Most of the disposed elastane will end up as non-recyclable waste once they have been worn out, because they are currently impossible to recycle. So synthetics produce a large amount of waste and damage the environment. What about cotton? Unfortunately, cotton has a large water footprint, 2,700 litres of water being needed to only make one cotton t-shirt, and around 80% of all textile articles bought in the EU are imported from non-EU countries using transportation. Putting all the facts like that, it sounds like we are doomed. Is there anything we can do to resolve this or help the issue? One obvious solution is to reuse and recycle clothes. Sometimes though, when clothes get old or break, this isn't possible, so there might always be waste. When cotton is used, more effective farming methods can be implemented. For example, drip irrigation, which delivers water directly to the root of the plant, so it avoids water waste. New research around this issue is always ongoing. One research group is looking into making textiles out of old plastic bags. This works because they only contain one polymer, which can be recycled more easily.